Hey everyone, and welcome. We all take for granted that Wi Fi just keeps getting faster, right? But the real story, the one that matters for professionals, isn't just about speed, it's about solving problems. Today, we're going to peel back the curtain on the evolution of Wi Fi standards and see what was really driving each new innovation. From that initial hunger for faster downloads to the really tricky efficiency issues that bog down our networks today.
Now, just so you know where all this great info is coming from, this is part 10 of a massive 20-part series. It's all based on a super detailed report on Wi-Fi and Bluetooth standards by the folks at RFI Detectives, who are part of Virtualization Options LLC. We're drawing straight from their expertise here.
All right, so here's what we've got on tap. First, we'll figure out where Wi-Fi fits into the whole wireless world. Then, we'll look at those first big jumps in speed that really put Wi-Fi on the map. After that, we're diving into a problem that every network pro has dealt with, the legacy client problem. And finally, we'll look ahead to how Wi-Fi 7 is being built to tackle today's biggest challenges.
Okay, let's start by setting the stage. Before we get into the nitty-gritty of Wi-Fi's evolution, it's really important to know where it sits in the grand scheme of things. You know, in our personal wireless world, there are two huge names that dominate, but they're actually built for completely different jobs.
And that brings us to a really fundamental question, one that's key to understanding how to design and manage a network. They often operate in the same airspace, so what is the real difference between Wi-Fi and Bluetooth? Well, this table pretty much breaks it all down. Think of Wi-Fi, a wireless local area network, or WLAN, as being all about high-speed data over decent distances. It's your on-ramp to the internet. Bluetooth, on the other hand, is a wireless personal area network, or WPAN. It has a totally different mission, connecting things like your headphones, your smartwatch, and all those little IoT sensors over a very short range, and doing it with as little power as possible. They are fundamentally different tools for different tasks.
Okay, now that we've got that straight, let's zero in on Wi-Fi's story. In the beginning, the evolution wasn't about fancy efficiency tricks or super low latency. Nope. It was driven by one simple, relentless demand from everybody. Just make it faster.
And you can really see that race for speed right here. The original standard from 1997, it topped out at a whopping 2 megabits per second. Yeah. The first real breakthrough was 802.11b, which cranked things up to 11 Mbps and basically made Wi-Fi a household name. But then, not long after, 802.11g came along and gave us that huge leap to 54 Mbps. That became the new standard for performance. But here's a really interesting footnote from that time. While 802.11g was being developed for that crowded 2.4 GHz highway, there was another standard, 802.11a. It offered the exact same 54 Mbps speed, but it did it in the much cleaner, less crowded 5 GHz band. So why did G become way more popular? The answer is right there in that last row, backwards compatibility. 802.11g could talk to all those 802.11b devices that were already out there, and that made upgrading a no-brainer for everyone. But that amazing feature, backward compatibility, it created a brand new and honestly a much more complicated problem. You see, as networks got better, performance wasn't just about the top speed of your shiny new laptop anymore. It turned into a fight for efficiency, for something called airtime. This is what we call the legacy client problem.
Now, to really get why this is such a bottleneck, you have to understand the fundamental rule of Wi-Fi. It's called CSMA/CA. It's a bit of a mouthful, but what it means is simple. Every single device has to listen to see if the coast is clear before it's allowed to talk. It's basically a politeness protocol to keep devices from talking over each other and scrambling the data.
So because everyone has to take turns, you get an immediate issue. Imagine you have one old, slow device on your super-fast modern network. That one device is like a tractor, chugging along in the fast lane of a highway. Every other car, every other device, has to slam on the brakes and wait for that tractor to finish its slow, long trip. It drags the performance of the entire network down to its level. The source material we're using just puts it perfectly. It says, the slow client monopolizes airtime, dragging down the performance of the entire network. And that's the key takeaway. It stops being about data rates and starts being about who's using up all the time. A slow client is, simply put, an airtime hog. So this huge airtime efficiency problem is exactly what modern Wi-Fi standards have been engineered to solve. Now, Wi-Fi 5 and 6 made some massive improvements for sure, but this whole evolution really culminates in the next great leap forward, Wi-Fi 7.
It's being designed specifically for the messy, crowded, mixed-device reality of the networks we all manage today. So let's look at the goals for Wi-Fi 7, also known as IEEE 802.11b. And just to be clear, that's 802.11be, not to be confused with that old 802.11b standard. The goals here go way beyond just raw speed. Of course, it delivers extreme throughput, but look at the other items. Ultra-low deterministic latency. That's a huge deal. It means the network gives you a super consistent, predictable delivery time for your data. That's absolutely critical for things like AR, VR, and cloud gaming. And this quote from the report really just hammers the point home. The design mandate was unambiguous: deliver extreme throughput and ultra-low deterministic latency for demanding real-time applications. You see, this wasn't about another small speed bump. This was a fundamental redesign of Wi-Fi to handle a whole new class of things we want to do wirelessly. So this leaves us with one final, and I think really important question. As the Wi-Fi itself gets this fast and this efficient, the bottleneck has to move somewhere else, right? So for all of you IT pros out there managing a network, the question is, what's your next weak link? Is it your internet connection, your core switches, maybe even the processing power on the devices themselves? Finding and fixing that next bottleneck? Well, that's the new challenge.